And here we go with the last part in our chapter, the domain of definition. Before starting about the domain of definition, let's press on the calculator. For example, 2 over 0 minus 3 over 0. Every time you press on the calculator any number divided by 0, the calculator will give you a math error, because we have to know that in math the denominator must not be 0 at all. So this is the main idea of the domain of definition. The main idea of the domain of definition is to maintain the values in which a fraction in that form is defined. And in order to maintain these values, you have to make sure that the denominator is not 0 and to exclude the values that make the denominator 0. So let's start talking about the domain of definition. F of x in this example is equal to x minus 2 over 3x minus 5. The question is usually to find domain of definition of f of x, or for what values of x is f of x defined. So the question is either find the domain of definition of f of x, or for what values of x is f of x defined. So you have to know the way of the question that's related to the domain of definition. So all what we have to look at is the denominator. The denominator here is 3x minus 5. So we just write 3x minus 5 should not be equal to 0. As if I'm solving an equation. I take 5 to the other side and then divide by the coefficient of x. And then the answer is that x should not be 5 over 3. So this fraction is defined for any real number. I can replace x by any real number and I will get a result except 5 over 3. That's why we write D, which means the domain of definition, is equal to R, the set of all real numbers except 5 over 3. Because when I replace x by 5 over 3, I will cancel 3 by 3 and I will get 5 minus 5, which is 0, and thus the denominator is 0, and by this the fraction is undefined. So this is what we mean by the domain of definition. This is how to find the domain of definition. It's the set of all real numbers R except 5 over 3, i.e. I can replace x by any number, by any real number, radicals, decimals, whatever, except 5 over 3. Here is another example. K of x equals x minus 2 over 3x minus 5 and x plus 4. Note here you have two factors in the denominator, so all what I have to do is to take each factor alone. 3x minus 5 must not be 0. Then x must not be 5 over 3, and also another condition, x plus 4 must not be 0, so x must not be minus 4. So I say here that the domain of definition is the set of all real numbers except two values, which are 5 over 3 and minus 4. That's to say that if I evaluate x by 5 over 3 here and here, and I will get 0. Also, if I evaluate x or replace x by minus 4, I will get 0 in the denominator, and that's undefined. P of x here equals to x squared over x squared minus 9. Then x squared minus 9 should not be 0. So I have to split to factorize x squared minus 9 and to split it into two factors. One of them is x minus 3 using the rule or the identity of difference of two squares, and the other one is x plus 3. Now solving each one alone, then x must not be 3 and x must not be minus 3. So the domain of definition is the set of all real numbers except minus 3 and 3. More examples on the domain of definition. Let's continue. Here is f of x that's equal to x minus 2 over x minus 5 into x squared plus 9. Again, I have to look at the denominator. I have to consider the denominator only. X minus 5 is not 0, then x is not 5, should not be 5. X squared plus 9. Why I didn't talk about x squared plus 9? Because x squared plus 9 is an always positive value. It cannot be 0 because x squared cannot be minus 9. That's impossible in R. Okay? So x squared plus 9 cannot be 0. It's an always positive value. Cannot be 0. So I just talk about x minus 5 and the excluded value is only 5. So the domain of definition is R except 5. Here is another example. X plus 6 over x minus 5 into x squared minus 9. So the difference between this and this is that here I have x squared plus 9 while here I have x squared minus 9. This can be split into two factors using the difference because I have minus in the middle. The difference of two squares will give me x minus 3 into x plus 3. So let's start by considering the denominator. First of all, x minus 5 should not be 0, then x should not be 5. X squared minus 9 should not be 0, then x minus 3 into x plus 3 by using the factorization should not be 0. Each one alone will give me x minus 3 should not be 0, then x should not be 3. X plus 3 should not be 0, then x should not be minus 3. So there are three excluded values which are 5, minus 3, and 3. So k of x is defined for all real numbers except 5, minus 3, and 3. Here is p of x that's equal to x squared over 2 minus x, all of it squared. 2 minus x, all of it squared, is not equal to 0. Then 2 minus x is not equal, should not be 0. So I cancel the square here. I just take 2 minus x. Okay? So x should not be 2, and then the excluded value is only 2. Okay, so the value that makes the denominator, the only value that makes the denominator 0 is 2 because 2 minus 2 is 0. And here, if solving equations, 2 is called a double root because I have power 2 here. So I don't need to solve 2 minus x twice. I just solve it one time as if I don't have a power 2 here. So let's continue more examples about the domain of definition and what we have to do after finding the domain of definition. Sometimes the question is like that: determine the domain of definition, then simplify, then solve. So for example, I have here f of x equals x minus 2 into 2x minus 10 over x minus 5 into x squared minus 4. First of all, I have to maintain the domain of definition, the defined values of x. So x minus 5, I look at the denominator, should not be 0, then x should not be 5. X squared minus 4 should not be 0, then I have to use the factorization to split x squared minus 4 into x minus 2, x plus 2 should not be 0, then x should not be 2, and x should not be minus 2. So the excluded values are 5, 2, and minus 2. Now, how to simplify f of x? So I'll start factorization. I start to factorize more and more. Here x minus 2 is kept as it is, while 2x minus 10 have a common number, which is 2. So I take 2 to outside, I put it here. 2x divided by 2 is x, and 10 divided by 2 is 5. So in the numerator, I have 2 into x minus 2 into x minus 5. In the denominator, I have x minus 5 into x minus 2 into x plus 2 by factorizing x squared minus 4 as we see here. Now how to simplify? I just cancel x minus 5 with x minus 5, x minus 2 with x minus 2, and what remains is 2 into x plus 2. Then I have to solve f of x equals minus 1. So all what I have to do is to take the simplified form and put it equal to minus 1, and then I have to cross multiply. Then I will get that minus x, because minus 1 multiplied by x plus 2 is minus x minus 2, equals 2 times 1. Now taking 2 to the other side, then minus x is 4, so x is minus 4. Why did I write accepted here? Because if you look at the excluded values, they are 5, 2, and minus 2. And since minus 4 is not among these values, that's why I say minus 4 is accepted. While if I solve f of x equals to half, then all what I have to do is to put 2 over x plus 2 equals to half, and to cross multiply again. 1 into x plus 2 is x plus 2, and 2 into 2 is 4. Then x plus 2 equals 4, so taking 2 to the other side, x equals 2. Why did I write rejected? You have to know. Because 2 is among the excluded values here, the values that x should not take. So that's why I will say that x equals 2 is rejected. So when I'm asked, does the equation f of x equals half have a solution? Because the required or the final answer is rejected, then I say that f of x equals half doesn't have a solution in R. And that's about finding the domain of definition, then simplifying, then solving. And we are going to talk about training exercises later, inshallah.